What is parallel circuit? Another essential method of connecting electrical and electronic equipment is through parallel components in circuits. A parallel circuit is defined by having the same voltage across each component in the circuit. Each component's ends are directly connected to the other, and two components are linked in parallel. Voltage. In a parallel circuit, the voltage is the same for all of the components. Current. The sum of the various branch currents equals the total circuit current. Resistance. Instead of adding up to a larger total, individual resistances reduce to equal a lesser overall resistance. Parallel circuit voltage. The voltage is the same across all of the components in a parallel circuit, which is the first fundamental concept to comprehend. This is due to the fact that a parallel circuit only has two sets of electrically similar terminals and that the voltage between those sets must always be constant. The voltage across R1 in the circuit shown above is therefore equal to the voltage across R2, which is equal to the voltage across R3, which is equal to the voltage across the battery. Applications of Ohm's law to simple parallel circuits. Ohm's law has the same restriction as it does for series circuits. The values of voltage, current, and resistance must be in the same context for the calculations to be accurate. We can't use Ohm's law on the rightmost, total, column since we don't yet know the total current or total resistance for this parallel circuit. The sum of all individual resistor, branch, currents must equal the total current, yet, if we pay C, a portion of the total current that leaves the positive, plus, battery terminal at point A and flows through the circuit splits off at point B to pass through resistor R1, another portion splits off at point C to pass through resistor R2, and the remaining portion passes through resistor R3. The total flow rates of all streams must be equal to the total flow rate, much to how a river divides into multiple smaller streams. The current flow from point G to point H must be equal to the sum of the branch currents through R1, R2, and R3. This is because the currents through R1, R2, and R3 unite to flow back toward point 8 and toward the negative terminal of the battery. The second rule of parallel circuits is that the sum of each branch current determines the total circuit current. The best way to figure out total resistance in parallel circuits. We may finally determine the total circuit resistance by applying Ohm's law. The resistance in parallel circuits equation. Only 625 ohms is less in the entire circuit resistance than any one of the individual resistors. The total resistance in the series circuit, which was equal to the sum of the individual resistances, had to be higher than any one resistor alone. The individual resistances don't add up to the total resistance in the parallel circuit, rather, we say that they decrease it. Similar to how series circuits were discovered to have three rules for voltage, current, and resistance, this concept completes our triad of rules for parallel circuits. In a parallel circuit, the overall resistance and individual resistances have the following mathematical relationship. 3 parallel circuit rules. In conclusion, a parallel circuit is one in which every component is wired to the same collection of electrically connected terminals.